So here we're asked to find the buoyant force on a balloon where the volume is given by 2 liters, which we're going to have to convert into MKS units to do much with it. So we're going to say 2 times 10 to the third cubic centimeters, and then to take that into meters, notice we want meters on top, we have a centimeters on the bottom. To get rid of 3, we've got to cube it. So it actually is not just dividing by 100. You got to watch those units. So your V actually becomes 0.002 cubic meters. This shouldn't be a surprise, right? A cubic centimeter might be this big, right? You know how big a milliliter is. But a cubic meter is going to be 3 feet by 3 feet. It's out of the screen, by 3 feet, basically. So it's big. You don't take just 1/100th of that and get a little tiny milliliter. Okay, so that's our volume. Sorry for the digression there. To find the buoyant force, we're saying that this is in air. So the buoyant force is going to be the density of the liquid. In this case, that's going to be air, times G, times the volume that's displaced. So we found the volume that's displaced, this 0.002. And we just need to look up the density of air. And so the density of air, if we look in our table, that is 1.29 kilograms per meters cubed. And so the buoyant force after all of this just becomes 1.29 kilograms per meter cubed times 9.8 kilograms. I'm sorry. Getting a little ahead of myself here. 9.8 meters per second squared times the volume displaced, which is 0.002 meters cubed. And when I look that up, this gives me 0.025 newtons, which seems pretty small. But balloons aren't heavy, so let's see how that compares to the force on the balloon if it's let go. That's really what it's asking. So if the mass of the rubber in the balloon is that, then we can figure out everything because we have an mg down and we have a buoyant force up. And generally with helium balloons, the buoyant force is bigger and so the balloon floats up. So let's find the mass. And the mass has 2 parts. The mass is the mass of the rubber balloon, the casing, plus the mass of the helium inside. Okay, so the rubber balloon we know is 1.5 grams or 0.0015 kilograms, to put it in our correct units. The mass of the helium inside would be density of helium times the volume, right? Because density is mass over volume. And so to find the mass of helium, we already know the volume, we just need the density of helium. And the density of helium is 0.18 kilograms per meters cubed. Notice it's significantly smaller than the density of air. And the volume that we had was 0.002, so this is going to be really small. And so mass of the helium is this multiplied by our volume, right? That's how much volume, how much helium we had. And I calculate that to be 0.00036 kilograms. So less than a gram. So we can add these two together to get our total mass is equal to 0.00186 kilograms. Not a lot of mass. So we can find now mg is equal to 0.018. That would be newtons. And so even though our buoyant force seems really small, notice our mg is even smaller, and so our net force that would be up, that would cause the acceleration. You could actually calculate the acceleration now that you have the mass, right? The net force up is 0.007 newtons.